The talk is Wi-Fi performance monitoring as a design tool. So like you guys, I have done a lot of Wi-Fi design, and I work at 7Signal now, and I'm using these kind of tools a lot. And so I'm thinking about what can these tools do to improve, augment the design process. I like to think about Wi-Fi performance monitoring tools in 3 different classes: hardware sensor, software agents, network as a sensor. At 7Signal, we do hardware sensors and software agents, but there are great tools from Cape Networks, Mist, Niansa, Cisco DNA Assurance, other guys. They can help improve your Wi-Fi designs as well. But I'm from 7Signal. We'll look at some of our data from our tools today. So a little disclaimer here. Not here to tell you that your design process is going to change a lot. You have to do site surveys, no way out of that. Follow best practices. But what these tools can do is give you more real-world data that you can take into your design and replace some of those assumptions with. So we'll look at some examples. So the first phase of design, requirements gathering. And Sam talked about the huge level of effort that takes, sometimes more than other phases of the design. And to me, that's essentially a visibility problem. So a Wi-Fi performance monitoring system, visibility is one of the big advantages, and that can help you answer some of these questions. For instance, what clients are out there? Often customers don't know, or they don't know exact numbers, or they may have, a bunch of Dell Latitudes, but there's a mishmash of wireless adapters there, and they certainly won't know what driver versions they have. So there are tools from these vendors, this is 7Signal Mobileye, that can give you a really precise client inventory, which can be really valuable when you go into capacity planning and other things like that. So here we can also see, like this is a software agent that runs on these machines, so we get visibility about the driver version, and we can identify this Dell Latitude here with an Intel 7260 NIC, perfectly good NIC, but really old drivers, probably want to call that out, let the customer know about it, or get it fixed before their bad Wi-Fi experience is blamed on your new design. Scott Lester made a great point about warehouse Wi-Fi and evaluating the space over time. Hardware sensors are great for that because you can put them out in the field, especially somewhere new where you don't know the RF environment very well. And you can find things like this source of interference that just annihilated the 2.4 gigahertz band for about 2 hours and then disappeared. Might not catch that in a site survey, depending on your timing, but it's good to know, especially if the customer is intending to do mission critical stuff in the 2.4 gigahertz band. And then there's a ton around capacity planning where we make assumptions about, such and such client with such and such capabilities should be transmitting at this data rate. And the same thing for APs. And that goes into the amount of throughput we can deliver to those clients. We can replace a lot of those assumptions with real data from the APs and clients that are going to make up the network. And some of that data is kind of surprising. So these are data rates from 2 different groups of APs. On the left is the last generation 3-stream 11AC AP, and on the right is the current generation 3-stream 11AC AP from the same vendor. And we can see the last generation AP was rate shifting up to those high 3 spatial stream rates much more often than the current generation AP. So if you were planning on, a lecture hall full of MacBook Pros with 3 spatial stream adapters, sipping airtime because they can take advantage of those higher data rates, this is important because with the current APs, that's happening less often. We can look at the same data from real clients. So now we're looking at the data rates that in one single cell from all 2-stream 11AC clients from the same chipset vendor. This is a high-density design, lots of SNR, designed to allow them to use high data rates all the time. So the right side of the chart is this highest data rates available, left side is the lowest. And what you see is, yeah, there's a big clump of high data rates in use, but there's a fat tail of low data rates in use as well. So maybe we need to be more conservative about our capacity planning when we're thinking about these specific clients. So this is all testable. And we can also identify clients here. Each line is a different client. We can see some clients are almost always at some lower data rates. Those might need to be called out and remediated. So when you build your design, you can take data like I just showed you and a whole lot of other stuff and use that to replace some of those assumptions you were doing before. You can give more real data to predictive designs, right? That their precision is only as good as the data they have. And then there's this whole phenomenon of surveyless designs, right? It's the wrong thing to do, you shouldn't do it, but it happens. And Wi-Fi performance monitoring systems can help out a lot there because there's going to be problems, there's going to be a lot more support tickets, operations costs are going to be high, and visibility and troubleshooting tools built into the network can help address that. So validation, again, it's a visibility problem, and that's the bread and butter of these sorts of systems. So you can have hardware sensors, portable sensors sent out to iffy spots to save you a trip to check on those areas. And software agents on clients can tell you a lot, right? You probably have a design requirement that says, I need to deliver a certain RSSI to every client. Well, let the clients tell you what their signal strength is. Find out about their roaming performance, because that's client side, it's not infrastructure side, but if it's bad, that's going to be your fault, right? They're going to come asking you why we're having bad Wi-Fi experiences after the new design was implemented. Clients can tell you about co-channel interference too from their channel scan results, and we can tell what their throughput is and application performance as well. So here's a little bit of data behind that. Here's a client. We can see roaming and Wi-Fi performance is good, signal strength is good, but problems with network reachability and throughput and application stuff. We can look at that data, see what their roaming performance is. When it's bad, we can call that out. We can look at their signal strength and data rate, make sure that meets our design requirements. We can make sure everything on the network they need to reach is there. And if not, have that addressed before everything's done, and then look at some performance characteristics as well. So when that's done, you can pass that on to the customer, whoever's going to take over operations, and use the system in a typical manner after that. Thanks.